So yesterday we did a quick introduction to the difference here between correlational relationship and causational relationship. Remember, our key thoughts are causation causes something to happen, right? One variable has an impact on the other, where correlation we see either no impact or an indirect impact on the other. So correlation, indirectly connected, or kind of a coincidence, versus causation, causing each other or causing one to change. So you've got a little background on today's activity, but I wanted to make sure we are good to go with the examples from yesterday. So here's our first one. Ice cream, well, first thing we want to do is think about, do I have a relationship here? So looking at the graph, I notice a trend happening in the line. This would be an increasing trend. So I know this is not an option for this set of data. I do see a relationship. Is that relationship indirectly connected or impacting each other, directly connected? So looking at our information, we've got ice cream sales and temperature. So the question is, does one of those factors impact the other? Can I say that temperature has a direct impact on how much ice cream people buy? Knowing what we know about temperature, as temperatures increase, I'm seeing more and more ice cream purchased. That one makes sense, that the initial temperature impacts ice cream sales. This would be a causation relationship. Temperature impacts directly the amount of ice cream people buy. Looking at our second example here, ice cream sales and shark attacks. Again, first question, do I see a relationship here? Is there similar trends in my data? Well, the answer is, of course, yes. The lines parallel each other. So again, I know this is not an option. So I'm down to my two choices. What type of relationship? Would it be correlation? They're just indirectly or randomly connected, or does one cause the other? So looking at my choices, ice cream sales and shark attacks. Can I say that the amount of shark attacks is directly related to the amount of ice cream people buy, or vice versa? I don't think we can say that's a direct connection, right? It's not one is making the other happen. There is an indirect connection, right? We know already more ice cream sales in the summer, right? When it's warmer, there's more people out, more people at the beach, maybe increases the likelihood of shark attacks, but is not directly causing them. So there's a mild connectivity, we call it correlation. Attendance and graduation rate. So bar graph, if we connect them up, here's our trend. We see the trend is happening, it's increasing. Looking at my variables, attendance and graduation rate. Can I say that the amount that you are in school is directly impacted the chances of your graduation, right? The more you attend, the more likely it is to graduate. This would be causation. One is directly impacting another. Looking at our data, our graph, do I see that the data is aligned? Is there some sort of trend? The green one rises, the purple one rises, green one dips, the purple dips, and so on. So the data is connected. So I know there has to be some sort of relationship. Correlation, mild connection, causation, one impacts the other. Looking at my variables, sour cream consumption. So amount of sour cream people are purchasing and eating compared to the amount of motorcycle accidents in that area. Can I say that the amount of sour cream you eat is directly related to your city's amount of motorcycle crashes? I cannot say those are directly related, So correlation is what we're thinking about. See a connection in the data. What is that connection? Correlated or causation. Cigarettes smoked and lung cancer. Can I say the amount of cigarettes you smoke is directly related to your chances of having lung cancer? Knowing what we know about those two things, we're definitely going to say one causes the other. Looking at the graph, relationship, as I look at the dots, I do not see a clear trend. There's no relationship here between your shoe size and how many movies you watch on a regular basis. Again, looking at the data, I do see a trend happening. The lines are similar. No relationship is not a choice, but what kind of relationship is it? Spelling bee winning word length and spider bites. Looking at my data, 2002, the winning spelling word was 13 letters. That means there was 13 spider bites. Are those directly impacting each other or an indirect impact, maybe just a coincidence? I'm going to go coincidence. They do not directly control the other factor. Again, I see a trend in my data. How can I name that trend in terms of amount of margarine or butter consumed related to divorce rate in Maine? As I see the amount of butter consumed goes down, less people are getting divorced. Are those directly impacted? That is a no. Looking at my graph, I definitely see a trend happening between the two pieces of data. Are they correlated or a causation relationship? Can I say the amount of CO2 in the air is directly impacting the global temperature? Knowing what we know about CO2 from our carbon cycle unit, hopefully you decided that was a causation relationship. It causes the temperature to change because CO2's job is to absorb solar energy. Last one, looking at my graph, I am not seeing a perfect trend or anything forming with the data, so there is no relationship between amount of coffee someone drinks and their IQ level. So you've got a little background now on this idea of correlational and causal relationships. Hopefully you grabbed this one from the weekly plan, because I made you some extra notes on here because I didn't want you to have to go into this program and kind of monkey around. I thought you could just see the graphs and try it. So I chose that you're going to be an expert on CO2 in the atmosphere, and I, instead of having you do the graphs yourself, I put them all in. So all the graphs are here. What you have to do is go through, observe each graph. You are the expert in CO2, so that one shows up on every graph. You have to first fill in what the other variable is on the graph, so looking at the Y, recorded in here. Then decide, looking at the graph that's presented, do you have a trend and what type of relationship it might be. Okay, so start by doing a quick refresh, plugging in some new definitions based on the details, maybe an example we talked about, and then looking at the scientific graphs, determine trends and relationships, if at all. After, of course, you've looked at what you're comparing by filling in the Y-axis.